Lesson 8504, Window Frames, Functions and Equations. In this lesson, you'll represent a function with an equation and identify independent and dependent variables. All right, today's lesson, if you worked through the activity on Desmos, there's a lot of great information there, but the notes are really important today for bringing all of the experience together. So after you go through the activity on Desmos, come to page 13 in your workbook, and let's talk about some of the things that we should nail down. There's two learning goals this time. The first one is we want to be able to represent a function with an equation. And we get two new words that we're going to deal with. We want to be able to name the independent and dependent variables in a scenario. Name the independent and dependent variables. I'll say in a function. Now we've been dealing with these all along as we've been talking about functions. We've just been calling them inputs and outputs. But today right now we're going to talk an awful lot about independent and dependent variables. Because you're not always told which variable is which. You need to do some thinking. So let's talk about how you should think about a scenario. So we have really three different scenarios that we're going to think, okay, what are my variables? And more importantly, which one depends on the other one? So in each situation, we're going to complete this table with a possible independent variable or dependent variable. Let's take a look at this first one. Here's my question. How many pickles can I make? Now I'm going to answer that with, well, it depends. Now they've already set me up for which one is which, but I have the dependent variable that's, questioning how many pickles can I make? And what it depends on is my ingredients. How many cucumbers do I have to work with? The number of cucumbers is going to determine how many pickles I can make. So those are my two variables. We have the number of pickles, and this depends on, the number of pickles depends on how many cucumbers I have to start with. Now we're going to spend a little bit of time with this one because there's a lot to say about independent and dependent variables. First thing I want to say about independent and dependent variables is that we've been talking about these all along. Usually when we're talking about the independent variable, we've been talking about the input. And we saw in the last lesson, that's usually the x value. But it's also, if we're talking like cause and effect, it's the thing that would happen first. It's the cause in the situation. So my number of cucumbers comes first, and that causes the pickles to happen. So let's talk about the independent variable as the output. You can almost think of it as you put cucumbers into the function machine and out pops pickles. The output is our y value. And this is the effect. So independent and dependent variables are really about cause and effect. Usually the independent variable happens first, and the dependent variable happens next because it's an effect of that independent variable. So I have cucumbers, and then I turn them into pickles. Cucumbers goes into the function machine, pickles comes out. So how many pickles can I make? Well, it depends on how many cucumbers I have. All right, well, that gives us a start. Let's look at this next scenario. How much does my ice cream cost if I get different amounts of toppings? Okay, well, they've already set us up with the outcome. the cost of my ice cream. I'm walking up to the cash register. The cost of my ice cream is the dependent variable. But what does it depend on in this scenario? What determines the cost of my ice cream? Well, according to this, it's the number of toppings I buy. So the cost of my ice cream cone depends on how many toppings I buy. Let's go ahead and put that in here. So I get a bunch of toppings, and that affects the cost of my ice cream cone. This is the cause, and then later on I go to the cash register, and this is the effect. Okay, it affects the cost of my ice cream cone. Now, this one's a little trickier because we're not given either one of these values. So we're going to have to figure out what the two variables are and which one causes the other one to happen. What are the two variables and which one causes the other one to happen? So how does sleep affect performance on tests? Somewhere buried in there we have two variables. It looks like we're talking about the amount of sleep that we get. And we're always telling teenagers, you need to get 8 hours of sleep. So how does sleep affect when we have a performance on a test? So let's think about those in a cause and effect kind of way. Which one causes the other thing to happen? Well, getting enough sleep, I would hope, would cause you to do better on the test. Or I could look at it the other way. How you do on the test depends on how much sleep you get the night before. So let's think about the cause and effect. Which one comes first? Well, I get a good night's sleep. So let's make the independent variable my hours of sleep. And a good night's sleep causes my performance on the test to go up, I would hope. So let's call the dependent variable the level we score on the test. So the sleep causes the score to happen, or we can say the score is determined by, or it depends on, how much sleep I get. See how this works? This comes first, and then this comes second. That's my output. Okay, now in the lesson that you did on Desmos, there were some equations. And what we need to know about equations is that whatever it's solved for, like y here, y equals, that's the dependent variable. That's what I get after I plug in something for x. This is my input, or my independent variable. That goes into the function machine. This rule happens, and out comes a y. So x is my independent variable. That's what I put into the function machine, and out pops my dependent variable. So whenever you see an equation, whatever it's solved for, that's the dependent variable. Its value depends on what you put into the equation. And just so we use that language of functions again, I can say that y is a function of x. Or I can say the level I score on a test is a function of my hours of sleep. Or I can say the cost of my ice cream is a function of the number of toppings I put on it. Or I can say the number of pickles that I get is a function of the number of cucumbers I have. So the dependent variable is a function of the independent variable. Or it depends on the independent variable. And I said in the last set of notes, is a function of is just another way of saying depends on. All right. So the independent variable, we've already kind of written it up here. We can say is the input. We can say it's x. And we can say it's the cause of the other variable. Causes the other variable. And on a graph, it's x, or the x-axis. So that's our independent variable. And that's where our input goes. Oop. Sorry, I didn't realize I was off screen. So let's answer these questions one more time. You might want to pause the video and put all this in. But the independent variable is the input, or x. It causes the other variable to happen. And how is it represented on a graph? It's this horizontal axis. Sorry about that. So the dependent variable is the output, or y, and it is the effect. That happens as a result of x. And on a graph, it would be the vertical axis. You'll see this in science as well. Anytime you see a graph in science, oops, meant to do that in green, all kinds of mistakes. In science, the dependent variable goes on the y-axis and the independent variable goes on the x-axis. All right, and remember to scooch up this time. Okay. So what's important in equations is that when we have an equation, whatever it's solved for, that's the dependent variable. So let's look at this scenario, but don't get too lost in the words, because the resulting equation is right here. So we're told that brown rice costs $2 a pound, and beans cost $1.60 a pound, and Rudra has $10 to spend on these items. And we're told that the amount of brown rice, R, is related to the amount of beans, B, that Rudra can buy. So, the more she spends on beans, the less she has for rice, and vice versa. And she wrote this equation, R equals, now I'm going to stop right there. R equals the fact that I have a variable equal to something. I'm telling you, that's the dependent variable. That's the output. That's what's going to pop out. Hope I said dependent. And that depends on what I input for B. There's my other variable. There's the beans. So I know that R is the dependent variable because the equation is solved for R. So if I want to know how much, let's see, what does this represent? The amount of rice. If I want to know how much rice I can buy, this equation sets me up. It's like, well, it really depends on how many beans you buy. So tell me how many beans you're going to buy, and we'll figure out how much rice you're going to get. Okay. So whichever variable the equation is solved for, that's the dependent variable. We're going to bypass this summary question at the bottom for today. I think this that we've got so far gives us enough information. Probably the most important part of what we need to say here is that is in this table. The independent variable is the cause, the dependent variable is the effect, and in an equation, equations are solved for the dependent variable. All right, good luck on the homework tonight. It's a lot of information to process.